Ladies and gentlemen, good afternoon. As I was introduced, I'm the president of EGEC. EGEC stands for the European Geothermal Energy Council, which is the industry association, and it's the voice of geothermal energy in Europe. Our main role is to have geothermal energy in the papers of the European Union, in the policies of the European Union. We have 120 members, industrial members, who are all contributing to the development of geothermal energy. However, geothermal energy as an industry is not yet a consolidated industry. In my day job, I am an engineer and managing director of two companies in France, active on the Paris Basin district heating system, and I have to open my presentation. Yeah, and which is one of the largest district heating systems in the world, and yes, okay, yeah, good, and which is the largest district heating system in the world. Our company is active since 30 years in the business, and we have lived, let's say, from the birth of geothermal since the 1980s to now, a huge development. Well, in the initial topic, it was announced that I will speak about the Pannonian Basin, because it happens that my grandfather emigrated from Serbia 100 years ago into Western Romania, but I don't speak a word of Serbian, which I excuse for it. And I am trained in the petroleum engineering domain in the Ploie school in Romania. However, my mother language is Hungarian. So this is all about me and my company. Well, as an EGEC president, I felt the obligation, a part of the main topic, to present you a bit of the market report, which is our main document analyzing the evolution of the development of geothermal energy in Europe and also of the tendencies in the industry, which is not completely disconnected to the topic which I'm going to tell you about the Paris Basin geothermal system. I will concentrate on heating. Why heating is so important? Because in all our life, heat represents 47% of the energy use, and this heat is used 42% in households and 39% in industry. So it's a quite amount of energy which we use it as heat. We are always coming into our house. Most of the time it's comfortable, it's hot, and it's normal for us to have a heated environment and a comfortable environment. But where this heat comes from, it's always not even. Geothermal energy is the unique natural renewable resource which can satisfy all sorts of uses, which comes from shallow geothermal energy with respect to heat pumps. It can provide district heating and cooling with all sorts of resources from aquifers, and can produce cogeneration from EGS, enhanced or engineered geothermal systems, and of course it can be used for underground thermal energy storage with piles or aquifers. And last but not least, geothermal energy is widely used in greenhouse industry and greenhouse operators now in the Netherlands, which is one of the largest producer of Europe, have been, most of them, in the tendency of converting their heating system to geothermal. Well, where we are now, we have reached in 2018 more than 3 gigawatts electric installed for geothermal and more than 300 geothermal district heating operations. And we should not forget that we have more than 2 million geothermal heat pumps in operation. Geothermal district heating has 5.1 gigawatts thermal capacity. Of course, the leading countries are those countries who have quite good resources, like Iceland in capacity for heating. In red is the heating, and it's the heating and cooling, and in blue is the electricity. And these countries are followed by Turkey, which are predominantly high temperature resources, and then it's followed by France, which has quite a high capacity installed. Well, this I've seen. Well, in 2018, well, there has been some development, some new projects in Netherlands, in France, in Serbia, in Belgium, in Germany. And, well, geothermal district heating is developing slowly, steadily, and you will see why we do not have a constant development. This is a bit a chart of showing you all the new plants which have been developed, one of which is in Serbia, and most of them have been developed in Netherlands, in France. Germany is picking up because you may have heard that the Bavaria government and Munich has the ambition of decarbonizing and converting the city of Munich entirely to geothermal by 2040. Well, these are the leading countries of number of geothermal district heating plants in operation, under development and investigation. We can see that France is a leading country, and followed by Iceland and Turkey and the Netherlands. Well, geothermal, it's, let's say, capacity-wise, Iceland is the lead, followed by Turkey, as you see the graph, and then by France. Well, the average size of geothermal district heating systems, obviously, these are in Turkey, the largest one, the 50 megawatts, and in Iceland, and then the average we can see in the neighboring countries stands between 10 and 12 megawatts. Of course, as it was said earlier today, that there are small communities eligible to geothermal district heating, which are eligible to smaller plants as well. This is the chart showing you the number of commissioned plants per year. Why this chart is going up and down? Because of the lead time needed to develop a geothermal project, which I'm going to explain you in a later chart. And this is a bit the chart which shows you what is the gap of deep geothermal heating and cooling with respect to objective, the National Renewable Energy Action Plans. And then we can see that some countries have huge gaps and some they are less, and this all can be fulfilled in some way or another by geothermal. Obviously, as I told you, the biggest plant capacity is in Germany, then it's followed by Iceland, and curiously, Eastern Europe with Croatia follows up, and then France still keeps on. What are the type of operators in geothermal? The type of operators out of the 300 plants, you can see that there are essentially public authorities, these ones, and then we have local energy companies. So what does tell us? This tell us this geothermal energy is driven essentially by local wish and by local community. And of course we have private operators in action, but these private operators more often are fulfilling the contracts like delegation of the public service. Well, this is a map which has been done through the European Technological Innovation Platform for deep geothermal, which is active within which EGEC is the leader, which shows you that more than 25% of the population of Europe lives in areas which are suitable to geothermal district heating and cooling. This is a fantastic work done by our friends from Hungary, mapping up all the district heating systems, the district heating potential, matching the resource to the demand, and showing us that basically everywhere in Europe under our feet you can have, especially Eastern Europe, high density of district heating grids which are eligible to geothermal district heating. Well, this is a bit the general business model, which is, I'm not going to enter into detail, but of course it should start with the customer, then it should follow up with the proposition and everything. Or every well, it's not seeing very well, but every item in red, it's more or less motivated either by politics or by financial. Well, going in harnessing energy in the deep earth, it's comporting risk. Everything which is below our feet, let's say, it's more or less unknown. So it's geothermal development comports a risk, which decreases with time when from the first well drilling and the loop test and the second well drilling. However, the investment goes up the reverse way, but the risk is mitigated. Well, many countries in Europe, like France, traditionally, and Netherlands, and now Denmark and the Walloon region have put in place risk mitigation mechanisms, risk insurance policies, or risk sharing mechanisms. Now EGEC is working on a project which is called GeoRisk, which aims at setting up risk sharing mechanisms for all over Europe. Well, I don't know whether this could be implemented soon, but we will need serious donors from the European Investment Bank, or which now sooner or later will withdraw his financing from the fossil, and I think the funds can be available to be reverted to geothermal risk-sharing mechanism in order to cover the risk. Why do we need this risk-sharing mechanism? Because a geothermal project, it's essentially turning around one or more doublets. If the operator fails one of the wells, then he goes bankrupt, and no geothermal is going to be developed ever on that city. However, if there is a risk-sharing mechanism, this risk-sharing mechanism could essentially cover an eventual failure or an eventual reduction in the capacity. I will tell you about that on the French mechanism. Well, again, how do we unlock geothermal energy? This is the vision of the European Technological Innovation Platform of deep geothermal. Essentially, what we are going now to have, we are going to have 4th-generation district heating grids with smart grids and with multi-energy grids, which you have heard already in previous talks today and yesterday. Well, this is what is needed for power generation. I'm not going to insist in that, but power generation and combined heat and power are related together because they provide a more efficient use of the geothermal resource. Well, this is again the combined production. This is integrating smart gridding and also multi-source, multi-energy systems, which are the future in our energy system and in our, I would say, decarbonized energy system. Now I'm going to the main topic, talking to you about the Paris Basin. Well, the Paris Basin is not any much different of the Pannonian Basin. It's a large intracratonic basin. It's a stable sedimentary basin with very little faults. And in doing so, in the Paris area, we identify a series of aquifers, shallow aquifers, lower Cretaceous aquifers, the target, the Rodogo Reservoir aquifer, which essentially supplies most of the district heating systems. And now we are going to explore a deeper resource, which is a clastic reservoir, which is rather unknown. But now we are in the process of drilling a new well and exploring that. Well, the Paris Basin development dates back to the 1980s. And then on the dots you can see there are doublets in operation, there are projected doublets, there are triplets. Triplets are the result of the fact that existing doublets have been converted to triplets, and new triplets are projected. This is by reconversion of the energy system. And nonetheless, we had failures in the Paris area. Failures essentially because of thermochemical shortcomings, corrosion and scaling, which have led to the abandonment of certain doublets in very short time and with a large debt to the people. Today, we are 49 doublets in operation. We are producing 1,100 gigawatt thermal hour per year. The number of hours of operation average on a doublet is 8,250 hours. And then more than 1,100,000 people are benefiting of geothermal district heating in all the area. Well, downtown Paris, we do not have any systems so far, but we do have shallow systems which are even ourselves, we have constructed some on Rue de Rivoli, where is the Musée du Louvre, and also in Rue Washington, which are emblematic avenues of the Paris area. Well, fortunately we did that at the time when there were no Yellow Vest protests in Paris. Well, approaching geothermal energy is I always tell to the audience that being a reservoir engineer is like being a prophet. You know, you have to find out how to squeeze water from the stone. But since Moses, nobody was so clever to do so. So for that, you need a reservoir engineering approach, an integrated approach, which goes essentially from exploration to feasibility, and you have to go through all the steps from offset data processing, from seismic data acquisition, modeling, essentially geomodeling, reservoir modeling, and then well architecture to design the most suitable production infrastructure which you can produce your energy. A typical geothermal district heating system in France or in Paris, it stays from one doublet drilled from the same platform, 2 deviated wells which are supplying a heat plant, and the heat plant is supplying by a substation the buildings all around by a heating network. It's a very simple system. all the geothermal system except a few are operated with a deep electrosubmersible pump, and they are benefiting of a reinjection pump later. What is covered by geothermal energy? If you look at low duration curve in the Paris area for a typical district heating doublet, that we can see that a yearly renewable energy source coverage is 66%, assuming a COP of 4 for a heat pump. Why 66% is very important? Because by the law, if you have a district heating system which is supplied by renewable energy, on this percentage you benefit of a VAT of 5.5% compared to 20% today. So it brings to the customer a lower energy bill. And this becomes very interesting to the communities, especially the communities which have population with lower incomes, where the city needs to supply heat as a public service. Typical well architecture. Typical well architecture, as I said, it consists in a doublet drilled from the same platform. The distance between the wellheads is about 10 meters. The production well has a pumping chamber, and then the diameters are classical. Casing diameters are, the upper part is 13.38, 958, and the open hole is 8.5. The spacing between the doublets in the top of the reservoir is about between 1,200 and 1,500 meters. The drill depth is between 2,000 and 2,100 meters. Why do we need double casing on this section, one would ask? We need double casing because we are there is a strategic aquifer, the Upper Cretaceous, the Albion Reservoir, which is a strategic aquifer for the Paris area. As you probably know, France is having many nuclear power plants, and some of them on the River Seine, and if one of the rivers get contaminated, then all the population is going to be supplied by drinking water by this strategic aquifer. So this net needs to be protected. Needs to be protected also that in case of scaling and corrosion, due to the hostile nature of the water, the geothermal water does not invade into this particular reservoir. Well, corrosion and scaling, this was one of the main topics which led to the abandonment of the doublets in the early 80s, and then for this, over the years, technical solutions have been developed. Our company has invented the downhole chemical injection line, which is a composite line which evaluated in time. It has an Inconel tubing reinforced with a bumper wire, and then now we added fiber optics to make it more intelligent, so we can make real-time monitoring. The downhole chemical injection lines goes down to the casing shoe and injects an inhibitor which is adapted to the thermochemistry of the water, which actually films on the casing, protects the casing against casing and corrosion and scaling. Well, how geothermal is integrated into the landscape? Well, here you can see, a parc à la française, where you see a town hall, which is actually a small castle. In front of the town hall is a parking lot. Below the parking lot is the heat plant, and you would never guess the wellheads are right in the park, and they are underground. Very often, well, every 10 years we have to come back to these wells, or every 5 years to pull out the pump and do well integrity checks. When we come with a small rig on site, people are asking us that, what are you doing? Are you looking for oil and gas? We said, no, we are looking for geothermal. Many people around the area, they don't even know that there are 7,000 apartments heated by this doublet, which operates since 1998. And they are surprised that they are already since such a long time supplied with renewable heating. This is another problem of the communities. They are not communicating enough that their city or their district is supplied by renewable heat to get maximum support of that. Well, lack of communication or bad communication can lead during election times also to the fact that the mayor in office, who represents himself, loses the election, because if the geothermal doublet is down, district heating is down, then he loses the election automatically. And who is guilty? The geothermal energy. But nobody says exactly how it works and how it operates. Well, here is we are dealing with urban area. This is a photo dating from 1982, there was a doublet which was abandoned on the bank of the River Seine. This is just a historical photo. It's very nice because you can see the Eiffel Tower behind. Well, it's not very clear, but anyway. So you can do it in a densely we are always dealing with a densely urbanized environment. Below here is our last emblematic project, where already on the site were two doublets, 4 wellheads, you can see them here, drilled, and the objective was to replace these 2 doublets with 1 new doublet. The 2 doublets themselves were producing 300 cubic meters per hour together, and then we designed a new well architecture, which I'm going to tell you in the next slide, by replacing the 2 doublets with 1, which is a capacity of 450 cubic meters per hour, by drilling subhorizontal wells. And this is a site where we have done our first composite well, anti-corrosion well site. How geothermal doublet works? Well, we have a pump, we have a heat exchanger and a reinjection pump, a filter, and that's it. On the supply side, we do have the heat plant, then we have the heating grid, then we have a substation, and then when you have the heat, then we have the buildings. What is interesting that every geothermal doublet benefits of a backup boiler. In case the system is down, backup boilers take the relay and supply the heat. Well, this is a bit in detail, a geothermal doublet with all the regulation. I'm not entering into details because I'm going to exceed my time. Risk and success, success and failure. This is defined by the couple of flow rate and production temperature, and all these are linked to the capex, opex, and the return rate of investment, and also the selling price, the euros per megawatt, and injection temperatures. So basically, by the economics, by the capacity of the source, which is the temperature and flow rate, and the economic figures related to capex, rate of return, and sell price, we can define in which where do we situate ourselves after having drilled our wells. These success-failure criteria are applied for the short-term guarantee in France. When a doublet has been drilled and it has been assessed, then if it's successful, of course, there is no payout. If it's situated in the gray area, there is a partial compensation to the operator. If it's situated below the red area, then it's a compensation of 80% of the investment cost. How much operation costs? Costs in mining infrastructure costs in between 10 and 10.7 million euros. Surface costs are between 11 and 14 million euros. In a total, for the geothermal district heating system, which is on average between 8 to 12 kilometers long, you have to spend between 21 and 25 million euros. We should not overlook also the cost of the operation and maintenance costs, which are divided into the mining. Well, mining for geothermal is not a politically correct expression, because we are producing a renewable energy which renews itself, but we are overproducing it by the high flow rate, so over the natural inflow. Well, they're having a debate on that. I'm not going to enter into details. Surface OPEX costs, which are power, chemical, heat plant. So we are ending up with OPEX which varies between 1.2 and 1.6 million euros for a geothermal doublet. Well, the break-even costs are, for the worst case, when we have to spend 25 million and 1,600,000 for a doublet, then we need to sell it at 81 euros per megawatt hour. That is very expensive in French standards. The best case, we are at 56, which is quite acceptable. However, the subsidy, the heat fund, which we benefit in France, the renewable heat fund, which is on the average 25% on the capex, brings us for the medium case of an acceptable sales price of 64 megawatts compared to 75, which is from gas actually in France. Well, geothermal projects takes very long time from start to commissioning is usually 5 years. We have a very long time for permitting, tendering, as we are dealing most of the time with public operators. They have very lengthy processes which hardly can be reduced. And permitting is very long in France. You have to wait 1.2 years, 1.5 years to get a permit to do that. Then we are hostage of the oil and gas industry with the supply of materials for the casing, for the drilling rig, for the equipment. So this is why we have always a gap of site preparation, drilling completion, which is between tendering and commissioning. I'm showing you now an example of where we innovated a sub-horizontal well. This is the site I mentioned earlier. As you can see, in the area, this is located in the southern part of Paris, we already have a lot of neighbors. All these areas which are colored, these are protection areas defined by the law for each operator, so they cannot interfere with it. Our site in question is situated here, and it already had 2 doublets implemented, and at that time, of course, the law was not in effect. Their influence in area with the blue sketch was already exceeding the neighbor, so they were already influencing the neighbor. So the idea was on this site, as I said, to replace the 2 doublet by 1 doublet by changing the architecture in order to optimize the land occupation, to have an added value to the permeability reservoir setting. Just for the anecdote, we were not in a very favorable reservoir settings, and the objective was to have a large surface area to inflow of the well. Well, for the well architecture, sub-horizontal, horizontal wells have been drilled more than 250,000 in the oil industry, but none in geothermal and none on this diameter. Well, because what we have done, we have changed completely. We have drilled an 8.5 section for more than 1 kilometer in the target reservoir. We have benefited of geosteering technology. You can see here an exaggerated view on the vertical view. We had to follow precisely the lighter layers are the more permeable layers, so we had to stay in the longest time possible, the longest surface possible to get these layers in contact with the well in order to secure production. So this is a very challenging exercise. It's very innovative. And it has been never done in geothermal, and in France we have beaten all the records of horizontal well drilling. The first well was 1,100 meters and the second 1,400 meters with an angle of varying between 87 and 94 degrees. This is a second project where we have revisited an anti-corrosion well concept. This is the well, you do it for life, zero maintenance well. It is on a site where the same, we had to renovate the existing site because they were already a doublet in operation, which consisted in a production well and an injection well. The production well was in quite a bad shape. It was producing about 150 cubic meters an hour, and this was quite unsatisfactory because the production declined. The well was strongly damaged by corrosion and scaling. So the operator decided to have a new production well after a certain time. So we have proposed him an anti-corrosion well concept. What does it mean then? We have drilled a large diameter, 20-inch hole, 20-inch casing, 13/3/8 casing to the top of the reservoir, and we have installed freely suspended composite fiberglass epoxy liner in the lower part, which is in suspension, and in compression on the upper part. This well actually is producing artesian, but it can produce a pump, and it does not need any chemical treatment downhole because the geothermal water never gets in contact with the steel casing. The steel casing is also on propping, and the monitoring of the integrity of the well is done by the pressure monitoring of the annulus between the composite and the steel casing. This concept, as I said, you have seen a photo. We have done it 20 years ago. It operates. It has been never shut down, and now this is in commission since more than 1 year. And this is the difference of the result. Well, here you can see a bit the composite tubing we have installed in the well. This threaded and coupled composite tubing resistant to 2000 psi. And this was the performance curve of the old well, and this is the performance curve of the new well in artesian load. So far, the well is capable of, it's operating constant flow rate at 250 cubic meters an hour. So he has a 2-fold capacity increase by this novel technology, high diameter. Well, these technologies are available. Nobody needs to go on this pathway, what we did in France for more than 30 years. These are available for all future projects which can be developed everywhere in large sedimentary basins. Thank you so much for your attention.
Thank you very much for this interesting overview, very deep dive overview on the geothermal case in France. One thing you highlighted the case of France. I think this is very unique. Aside from strikes, we are the Parisian region is known for these developments. What can we learn from this approach of like risk reduction through the design and work to access financing? In France, we have, I'm French, I know a bit, some financing to develop those projects. How this approach of reducing risk, phasing the projects, and moving to implementation in a very cautious way, how can we learn from this experience in here today in the southern European countries?
Well, compared to France in Eastern Europe, and this was the object of my question earlier today, how can you access the data? We all know that Eastern Europe, where I'm coming from also, it's very well explored by drillings, by oil and gas drillings. Access to data is crucial. The risking by available offset well data, by seismic lines, complemented by new seismic lines, it is essential factor of the risking in establishing the precise target of the well. With the reservoir properties, provided that we had drill stem tests for the aquifers, which was not always the case for oil and gas industry, we can rely again on offset data. So this is another process of the risking. So as I showed you, the integrated reservoir engineering approach, you have to do it systematically from primary data, from offset data, from neighboring wells, from modeling, in order to minimize the risk. Actually, you have to arrive when you come to the financing with a, I would say, not to a risk, but with a probability of success, which is more than 95%. So this is my answer. Now you have geothermal energy shares both the exploration risk, as I said, and the exploitation risk, because, well, for Paris area, I can tell you we do have the water, but we don't know. Well, we know the salinity, but not two sites are identical with gas composition, with the water salinity, with temperature. Well, the northern part of the area is colder, the southern part is hotter, the eastern part is even hotter. So you have different thermodynamic conditions. This is part also on the risking phase. How would you handle hostile thermochemistry? What are the equipment which are developed? Now I presented you quickly downhole chemical injection line, which is an intelligent line which you can follow in real time the well integrity, and this now can be also now seismicity, microseismicity is a big topic. We can integrate a combined line in order to measure vibration and pressure. So these are technological evolution, geoscience evolution, in order to have a project with a probability of success more than 95%.
And from extrapolating from this French experience, in your presentation you had a lot of valuable information on European platform. Based on your experience, local, regional stakeholders present today, are they active in those European platforms, and how can they access those platforms to work on those topics?
European Technology Innovation Platform is open to everybody. You have to go to the site, register. You have access to the information, the reports, the meetings. The meetings are free. You can participate. They are taking place in Brussels, in Pisa. We have regular meetings. You can contribute. There are working groups addressing work, drilling, their completion, addressing technology, production. So we have work groups. You can volunteer in the work group and can contribute with your ideas and also share your information and benefit of the information shared by the others. The great merit of the European programs and the European Technological Innovation Platform is they reunite scientists, engineers and industrials in order to share information to have better projects.
And to complement as well, many projects are multi-countries, so in many occasions, stakeholders from the public and private sector can join projects and actually getting finance to work on district energy, geothermal, low temperature geothermal projects concretely, and with the support often by full grant by the European Commission. let's open the floor for a few questions. Okay, I think it means your presentation was very clear. So thank you very much for this overview, and of course all those information will be available as outcomes of those meetings shared by Arena and EBRD. Thank you very much.